Hello and welcome to this lecture where we'll come into OOP, Object-Oriented Programming in Python. In this lecture, we'll go through classes, we'll go through instances, attributes, docstring, type hint, and much more. And in the optional parts, there's also encapsulation and properties. With this, I would like to go immediately to Visual Studio Code. So here I'm in Visual Studio Code. I have my virtual environment set up. I'm using UV. So if you don't know how to do that, look at my previous videos, how to set it up. And now I have a Jupyter notebook as well. So here's Python Fundamentals Part 3. So this is the OOP part. So starting with a class. So you can see a class as a type of blueprint. And from the class, you can instantiate instances, right? So let's create a class now. Class, let's see. I've written this in Swedish, actually. I've written this in Swedish, but the name, antagning, I could call it admission. Admission. So this is a class which has an initializer. So def dunder init. Let's see, def dunder init. And this initializer, this is the code that will be run whenever we instantiate from this class. So when we instantiate from this class, we get an instance, then this code will run first, the code inside of the dunder init. And it's called dunder when you have two underscores here, before and two underscores after, which there's a special type of method called dunder init. So it has a special meaning with it. There's a lot of other dunder methods. They are written in this way. So we have self as an input. So you send in the instance itself. And we use school as another input. We have program. We have name. We have accept as an input. So these are inputs, input arguments to this class, to this dunder init method. Okay. So then I would like to do self dot school equals to school. And what does this mean? It means that when we instantiate this class, we instantiate an object from this class, we put in an argument for school, and then we give an attribute to this instance that's called self.school. So self is the object instance itself, right? And this instance has an attribute called school. So this is how it works. And we give it the value school. And then I will do self.program. Program equals to program. And I do self.name equals to name. Self.asset equals to asset. So basically like this. So what does this mean? Let's create some students from this. Student 1 equals admission. We call it cool school. We say the program is AI. And note that these two are positional arguments. And now I use just to show that we can. I'll pass in some keyword arguments as well. And I don't need to put them in order when I do keyword arguments. So asset equals true. Name equals Koksha. And yeah, that is it. So then we have student 1. I run this one. Okay, when I run this, what happens? We have something here, dunder main.admission at some kind of hexadecimal memory address. So this is basically how Python denotes an instance of a class. So you have an instance, and so it's in the dunder main, and it's called .admission at some kind of memory address. So this means that this instance lives it's somewhere here. It lives in this address 0x103 something. And what is written out here is actually this class default dunder wrapper method. We'll come into dunder wrapper a little bit later, and I'll show you how that works in order for you to overwrite this default value here. So let's create a new code. Let's do student2 equals to admission of Cooler School, another school here. We let you go into data science and accept equals false. Yeah. And your name is Goreboard. That's the cool name. Okay. Student2. Oh, you're also an instance living in a certain memory address. But they're not the same memory address, right? So we have 10 in the end here. We have 90 here. Or 90. I'll actually increase this one a little bit so that it's easier for you to follow. I close this down. And I will close this down as well. Like this. Okay, so let's move on. We try to use student1. We can take out the program, for example. Program AI, right? Student1.name Coction. Student1.accept. True. Okay, so you can see, in order for us to get the attributes, we use the instance name. So remember that we have an instance here. Let's see. So student1 refers to this one. So we instantiated. So here student1 is here. So we instantiated student1 as an admission instance. So it's an instance of this class admission with these properties here. Or these attributes. So then, in order for us to get those attributes, we use the dot notation here. So we have student1 dot program, then we get the program attribute. Student1 dot name, we get the name attribute. Student1 dot accept, we get the accept attribute, right? So moving on here, we could do student2. Student2 dot name Goreboard. Student2 dot accept false. Okay, so now we could actually change these attributes on the fly. So it means that when we can change it after we have instantiated an object or instantiated an instance of this class. For example, I could do it like this, student2 dot program. I can change it to something else. I change it to UX. So then if I do student2 dot program, and I get UX, right? So now it's overwritten the old one. So let's do like this. We will check out, go in a little bit about we can check the memory addresses. So we can do ID of student1, and this is the ID. And usually they're represented with hexadecimal. So we do hexadecimal. So this is the memory address, right, of student1. And hex of ID of student2, you can see they're different memory addresses. It's here 1035.1, 1035E. Okay, great. They're different. Okay, so now we have checked the memory addresses, so we can go into the Dunder wrapper, which I talked about before. So Dunder wrapper. Actually, I think, yeah, this one gives bold text. So we need to do underscore here for the markdown syntax, like this. And escape Y to make it into Python cell. So this is Dunder wrapper. So it's spelled out. Let's see. Dunder wrapper. This is how you read it out. And this is what is this? This is a method for representing an object or an instance. So usually I use the word instance, but you could use object as well. So basically, this represents an object. So you could, for example, if I write, I can do like this. I will copy, I will go up, I'll copy this one. So this is the admission. And if we have, for example, I will have student 3 here, admission of school, Haskell, and your name is Ada Lovelace. And you have been admitted true. So student 3. So you see this is the wrapper. So similar as before, but we can now override the default wrapper. So def Dunder wrapper. So what I want to do is return a certain value. I want to return a string. So I'll do an f string, admission of school equals to self.school, comma, let's see, comma, program equals to self.program, comma, name equals to self.name, comma, accept equals to self.accept, like this. So why do I do like this? When I run this one, you can see now this is my wrapper. Admission, school equals cool school, program equals Haskell, etc. So this is actually a string. Cool school is a string. So I want to show that this is a string. I'll do quote here. I'll do quote. I'll do quote. Name is also a string. So I'll do quote there also. Accept is a boolean, so I won't do quote there. Okay, much better. Actually, I could clean it up a little bit more, but yeah, because I've started doing that, I will continue doing that. Okay, like this. So basically, with Dunder wrapper, you want to show to other developers and also to yourself how you would use this class. So that's why I've written with the class. I've written out this particular instance, its attributes or its parameters, arguments that have been used together with the parameters. So this is the Dunder wrapper. However, so the wrapper is represented in GPT Notebook when you just write it out like this, student 3. But you could do wrapper of student 3 and you get the same result here. And also you could do string of student 3 and you get the same result. How come? The string actually looks for a Dunder method called Dunder str. However, if Dunder str is not implemented, then it will default to the Dunder wrapper. So this is quite good to know whenever you're working with Python's normal functions, and you can see that you will notice how its wrapper and string works. Okay, so moving on, we'll come into some documentation. So working in a team and you're making classes, it's very important that you document them. So let's go into documentation. And in documentation, there's something called docstring, and there's something called type hinting. So these are two concepts that are really good to know. So let's do that. So class student. So I create a new class now, student. And I will have depth under init, name, string, age, :in. So this is type hinting. Active, bool. It returns none. So this is the under init method. So if you look into this one, let's see, I will show you soon. I'll do self.name equals name, self.age equals age, self.bool equals bool, like this. Or no, not equals bool, self.active equals active. And I will have a wrapper as well, run the wrapper. Self, I'll return string, return f-string, student. Actually, maybe I could do like this. Or no, I need to do that like that. Name equals to self.name. Age equals self.age. Active equals self.active. I'll have this enclosed in single quotes. Okay. So if I want to create a student instance, so look here what I'm doing. I'm just hovering over it, and we get name as a string, age as an int, active as a bool. Okay, so this helps me as a developer, and it helps other as developers to use this class. So then I know that name must be a string. So for example, here we could have Gore board. You are 55 and it's true that you're S1. Yeah, the naming of these classes and instances are not really good. Or classes are okay, but instance not very good. But here you can see the wrapper here. So you can see how useful this type hinting is. So let's continue now. You can actually do like this. Whenever you're working with classes, you can create a documentation by using an LLM such as ChatGPT. So for example, I could do like this. I could copy this one and move on to ChatGPT. I'm going to ChatGPT here. And I'll type, give me a docstring of the following code. Add some examples and make it readable. Okay, so then I get a docstring here. Okay, so I can copy back this code, close it down, paste it in. Okay, you can see there's a lot of code here, and it seems to be quite a little bit hard to read whenever you're working with the code, right? However, you can close it down like this using this for elapsing it. You could elapse it and you can see your code here. There's probably some kind of hotkey for collapsing this. However, let's look at what ChatGPT has generated for us. So some kind of description of our class. So represents a student with a name, age, and active status. Attributes. And these are attributes. They have name as a string, age as a string, active as a bool, and some description. Okay, right now this is quite simple class, so it does it quite well. So active status of the student, e.g. enrolled or not. Okay, actually this is not what I wanted. So active status of the students, e.g. enrolled or not, means, for example, for my student case, maybe I would like to, if they participate in class actively, like this, for example. So I, as a domain, I have domain knowledge of my class, so I know it better than ChatGPT that does it, that can come up with general solutions. Be aware that you need to change it so that it adapts for you. It shows some methods, it shows different examples. And you can, so it's also, you use 3 strings, 3 quotes in order to do multi-line strings. And you do it you write it in the beginning of the class. So this is the documentation of the class. So it's a doc string. And then you can document each method. So dunder init, dunder wrapper, right? So this is a complete doc string. You might need to change it a little bit for adapting for you, for your case. However, what can you do with this? If I write, for example, student, and I hover over it, you can see here's the documentation. Initializes a new student instance, some arguments, and this is for the type hinting, right? So also you could do help of student, and you can see this is the documentation that we wrote. So you see student, represent a student, attributes, methods, and examples, right? Of how to use this student. So cool. We have generated some documentation for our student class. But whenever you're writing more custom classes that are not as general as this one, it's much better to write your own documentation than to use ChatGPT. And also make sure, if you're working inside a company, if their policy allow you to just put this into an LLM, or in that case, which LLM, etc. And also if it's some very custom class that you're using for your particular application, maybe these LLMs will be totally wrong. So make sure that you write your own documentation. And also, but you could follow this structure. The structuring is quite good with the attributes, the methods, the different examples. So it's good structure. Great. So in the lecture notes, I also have encapsulation and private attributes. Actually, it's quite good to know them, but I will skip it for this particular class. So you should look into this lecture you should look into the lecture note yourself. So I will skip the properties, I'll skip the private attributes. And this is actually the end of this OOP lecture. Good that you have followed along, and I hope that you learned how to use different attributes, different methods. Actually, I've shown just the dunder methods, but you could do a method for basically anything. So you can see it's a function that is bound to the class. That's basically what the method is. And you've seen a little bit how you instantiate classes, etc. So this is meant to be an introduction to OOP. So it's nothing fancy. We'll keep it for some future lecture where I'll go into more advanced OOP. Yes, but thank you for watching this video, and see you in the next one. Bye.